Ladies and gentlemen, welcome back to another live stream. So in this live stream, I'm going to start a pretty interesting series in C++. So we're going to be creating a web browser from scratch. So obviously I got to start with some important things to say. First of all, I don't know if I'm going to be able to do this. So we're going to be doing this live basically and trying to see if we can actually achieve this or not. We're going to try to use as much modeler libraries as possible. We're also going to be using AI to assist with stuff and maybe even an agent, though I'm going to try my best to write all the code and only prototype with the AI, because I've actually tried to use the AI agent a lot in the past, and sometimes you easily lose track of the project. So we're going to try to write every single line of code ourselves, essentially, and only use the agent for prototyping and planning. But we'll see how that goes. Otherwise, we're also going to be trying our best to do some, good unit tests. I'm not very much a unit test guy, but we'll try. And yeah. All right, so live. All right, let's pop out the chat and let's go. Okay, so I think we're good now. Yeah, we're good. All right, so I guess let's already start a project if everything seems great. Yeah, everything seems good. Okay. All right, I guess let's already start a new project then. Okay, so I already got like something done in the previous live stream using an agent that helped us set up Skia at least, and some other Vulkan stuff. So we're going to be inspiring from that, though we're going to be rewriting everything ourselves. Just to make sure. Otherwise, we're good to go. Okay. So yeah, all right, let's start. So we're gonna go with the latest C++ 26. Why not? We're not gonna bother too much with cross-platform compatibility, at least for now. We're only gonna bother with modern GPUs and like modern stuff essentially. Otherwise, yeah. Okay, so let's just get started. And what we're gonna call this? Kodotaku Web, I think. I mean, Kodotaku Web. And yeah, we should be good to go, right? Okay, cool. Create, and let's go. So as for the libraries, what we're gonna use SDL3. We're gonna use Vulkan 1.4 with VK Bootstrap to remove some of the Vulkan Vulkan boilerplate. We're going to be using a lot of modern Vulkan extensions, for example, the swap chain ones. And for the HTML and CSS parsing, for now we're going to be using, what is it called? Light HTML. So there is this library called Light HTML, which you basically give it the HTML and CSS of a page, and then it goes ahead and parse those and layout it, and it just spits out some rectangles you can draw into the screen, which we could basically draw using our Vulkan SDL and Skia setup, essentially. And what I really loved about this project is that it doesn't have any renderer, and it doesn't assume how you're going to render the page. It just gives you some callbacks, not callbacks, but like, virtual functions which you could implement, and then you could do whatever the heck you want, which in our case we're going to call into Skia renderer. Right, so it uses Gumbo parser for parsing HTML apparently. And yeah, now honestly, in the long term though, I want to use another library that I feel like it's probably much more, we could have like more control in and much more mature, at least when it comes to parsing HTML, CSS, etc., which is Lexbor. But guys, if you have any other library suggestions, please let me know in the comment section or in the chat. All right, so there's this Lexbor, and hello Urbanil, welcome to live stream. Let's go. The code of all attack. That's interesting. Okay, so Lexbor is development of an open source HTML render library. Okay, so this is the one that I want to use in the long term, but to actually use this, there's gonna be, because we're gonna be writing our own layout system and gluing stuff a lot, which is gonna take quite some time. Because as you can see here, the layout fonts and stuff are still in progress apparently, though this library is actually being used by PHP to parse HTML and CSS. So that's pretty sick. I believe there was like some story I've seen about PHP have migrated from something to Lexbor, and I don't remember. Okay, hold on a second. So what we're gonna do, we're gonna say, so what is it called? PHP. PHP uses Lexbor, but what it was using before that. Let's see. Yeah, okay. So it was relying on libxml2, because at the start of it all, you know, people were just using XML to parse HTML and stuff. But that turned out very badly. And there was even like XHTML from what I've researched so far. But as you can see, so which was introduced to power the new modern HTML5. Yeah, so like when it comes to HTML5, they added a lot of extra syntax and stuff, which just broke everything down, especially as the web stuff started to really like assemble. On the other hand, I want to mention something that, so when it comes to web browser and such, I find a lot of people, what they do is that you either have these people that creates everything from scratch and they use no libraries at all, and these people just produce nothing, though they do obviously learn a lot and they do really know their stack very good. So I really love it for just learning stuff and figuring out how it works. And then on the other hand, there are people who create everything in JavaScript and these higher level libraries and engines, etc. So you have these kind of things, these kind of poles or extremes, but we're going to try to go to the middle. So we're going to be creating our web browser, hopefully, if we are successful in doing it. Obviously, this is just mostly for learning purposes, but you never know. I'm going to be making this hopefully open source and everybody could like contribute into it. And the real trick here is that we're not going to be bothering to implement everything from zero ourselves, like the HTML parser, the CSS parser and such. Because you're gonna take a decade and you're never gonna finish anything at all. The same thing with the render. We're not gonna be creating like a render from scratch using Vulkan. Again, that's another complex task by its own. Instead, we're gonna be using a decade of experience of Google engineers, sorry, in the Skia render, which is being used in the Chromium, which basically everybody uses nowadays. So yeah, obviously at some point we could possibly replace such libraries with other libraries or even our own custom implementations. But my advantage right now, I'm trying to take advantage as much as possible open source libraries so we can get something working as fast as possible. And that's the trick here. Okay, so Sanatani, welcome to the live stream. Can you check VK Bootstrap from Charin? This is also good. Yeah, definitely. I'm going to use that. In fact, I used it in my previous live stream where we explored Skia, and we had a lot of fun in the first hour. I couldn't get it to work. Then we actually switched to the open, what is it called? Open Code Agent, which is actually have a free model called Big Pickle. And it really helped us get the at least Skia working and some prototype that we're actually going to be getting code from in this live stream for setting up this stuff. I mean, I could have just started from the previous live stream code, but I want this series to be self-contained, and also the fact that I had some problems working on that, like the project that the agent made by itself, because I lost track of some details, like for example over the swap chain resizing, and I had some trouble with that and I couldn't really track down the stuff easily. So I found myself that I had to kind of read the whole thing, which honestly I'm not really great at. So I really understand a project by just writing every single line of code. So that's why we're gonna change. Also, another problem that I had with the projects that the agent makes is testing. It can't really test very well visual projects, so like render stuff, etc., and like the Windows stuff. So we're not gonna do this now, but later on, hopefully I would try to separate the project into at least two sides. One side that is have no render or anything, is just like the state of the program, which could easily be tested without graphics, essentially. So the agent itself even could test it easily and could write unit tests for it and stuff. And then another side where we're gonna have our Skia, our Vulkan SDL, which we're gonna test ourselves using graphics. I'm not aware of some, you know, like testing toolkits for graphics applications, but we'll see if anything comes up. If you guys know anything about that, please let me know. But yeah, so that's the plan. But for now, we're gonna start with just one single project with one layer where everything is in one single file. Then later on, we're gonna try to split that up, basically, refactor it. But yeah, all right, because I found that much better than just trying to abstract on the fly, you know. It just wastes a lot of time and stuff. But anyways, all right, so before PHP adopted Lexport, which was introduced to power the new modern HTML5 compliant DOM features starting in PHP A4, PHP relied entirely on libxml for its core XML and HTML parsing via the ext DOM extension. Okay, so the era of libxml2. For decades, PHP's DOM documents simple XML element and DOM XPath classes were thin wrappers around libxml2, a highly robust C library written by Daniel Weird. While libxml2 is brilliant for XML parsing, using it for modern HTML came with significant drawbacks. So it's stuck in the HTML4 and HTML era. libxml2's internal HTML parser was written over 20 years ago. It has no understanding of HTML5 elements like article, section, nav, or video. And then you got the tag soup problem. If you try to load modern web pages using DOM, load HTML, libxml2 would often panic over enclosed closed tags or new semantic elements. So if you try to load modern web pages would often panic over enclosed tags or new semantic elements, I see, throwing a barrage of warnings and fundamentally altering the DOM structure in unexpected ways. And lack of what WG compliance. Modern web browser parse HTML using strict algorithms defined by the WG standard. libxml2 does not follow these rules, leading to discrepancies between how PHP viewed a DOM tree versus how a web browser did. Now, why PHP moved to Lexport? To fix this without breaking decades of legacy code, the PHP internals team introduced a brand new class architecture in PHP A4 like DOM HTML documents powered by Lexport. The old classes DOM documents still use libxml2 under the hood to preserve strict backwards compatibility, but the new classes use Lexport, giving PHP native blazing fast and 100% WGB compliant HTML parsing alongside modern features like native CSS selector support. So apparently some of these is coming from this blog, and I'm going to share with you the link. And in fact, maybe after the live stream I'm going to read this whole blog myself, but here we go, it's in the chat. So this is kind of like what I referenced essentially. But anyway, so this is just a little bit of history, because it's very important to learn about the history to see where things have gone wrong and stuff, etc. But other than that, we should be good to go. Alright, so I think maybe let's just already start the actual code stuff. Yeah, sure. Okay, I believe there was a way to, hold on, window, layouts, save the current layout. Let's just save the changes. Okay, cool, nice. Alright, so what we got here? Hello world. Okay, so now for the actual libraries, how are we gonna do this? So we could either use git submodules, or we could use the CPM, And for that, I think I'm gonna try to use CPM. And you know why? Because the thing is, I'd like to use fetch content, but the problem I had with fetch content is that whenever I used to like remove, what can I say, like delete the build folder so I could, you know, retry something or whatever, then it would basically like remove the whole downloads or downloads. Then basically you have to re-download everything first, then rebuild everything, which sucked. But apparently CPM is like just a wrapper over fetch content, which I actually used before in this channel, but then I kind of abandoned for VC package and get some modules. Now VC package, it's interesting, but it's kind of like a black box. You don't have that much control over how stuff builds. And the other one, also you could have like some very outdated versions of libraries, or you could find no library in VC package, like the library that you want. The other thing is get some modules. What I really like get some modules, but it kind of, especially if you want to automate this process of downloading dependencies, you kind of have to go ahead and say get some module add blah blah blah. You have to have a git init repo, etc., which kind of suck. So what I'd really love to have actually is to have like a submodule, like a, what can I say, a separate project which have like a collection of, you know, library find modules which you could easily include into any project you want, and then you would get it easily. Let me show you how that would work. But right now let's just start simple. So we're gonna include CPM, so GitHub cpm.cmake, and let me show you what I'm talking about. So if we go, for example, to the wiki, so the wiki of CPM here, where's the wiki? There we go, I believe, yeah. And as you can see, there is caching with CPM, CMake, and I think this is the one, right? Not really. There is another one. Hold on. Maybe it's in the README actually. The README. And in CPM, the usage. Yeah, also a little bit more convenient in writing instead of fetch content. Other than that, okay, where is that thing? Dependent. So first of all, there we go. There is this variable called CPM use local packages, which basically would allow you, and like fetch content, would allow you to use the local packages that you have already downloaded. So you can actually use it, you know, offline essentially. Other than that, what else there is? Package, there's even package log files. I'm not sure how that is that different like from the commits tags, but yeah. What else there is? Automatic shallow. It also does automatic shallow clone. I mean, you could do it using fetch content, but you have to constantly every single time remember to add those extra tags, like those extra parameters, etc. And CPM source cache will perform. And there's another one, I think. Yeah, there you go. There you go. This is what I'm talking about. So you just set the CPM source cache variable to some folder, and then it would keep on using that folder to grab the dependencies instead of re-downloading again and again, which is sick. All right, so first of all, what we're gonna do, we're gonna grab the CPM script, and for that, we're gonna go back to the wiki, and there is download CPM in CMake here, and you're just gonna grab this guy, right? cpm.include cmake, cpm.cmake. All right, sure, fine. Let's just put it, I guess, maybe here. Okay, so this is how you download CPM. Next step, what we're gonna do is we're gonna copy one of these guys. Let's see, CPM add package, etc. So you just say gh actually, and the colon and the repo. Okay, so for example, let's go with SDL3. So if you go to the SDL3 GitHub library, here's the thing that you need to copy, right? Just this, and then you go back here, and then you say cpm add package. So that's why a lot of people don't use libraries in C++ ecosystem, because it's just very hard to deal with CMake, and like everybody's using their own kind of build system and package manager, etc. So it's just in shambles, and there's a whole sorts of like compilers and also build flags and systems. So that's why a lot of people don't do that. But to me, I think CMake is like the most used build system, so I just go with it. And it's not bad once you get used to it. It's not the best ever, like language to use either, but again, it's the most used, and it just kind of works for me for now at least. But yeah. Okay, so here the releases. What I usually do is that I see if the release is recent, which in this case last month. It's pretty good, so I'm just gonna go with that. So I'm just gonna copy this release tag, and then I believe you just say this, right? Let me just verify though. Actually, it's probably this, but let me verify. Yeah, so for the tags you use this hashtag, but for the versions you use this. So I'm just gonna go with the tags here. So we're gonna go with this release 3.4.10. Next up, we're also gonna pull in the Vulkan headers. This is not required. You could just like download the SDK, and for example in Arch Linux you just say sudo pacman-s Vulkan devil like this, and then it would basically install all the Vulkan stuff you need for development, the SDK, etc. But for example, when using, let's say, for example, when someone clones your repo and tries to build it and they don't have the Vulkan SDK, it would fail. This is the first problem. The second problem is that the agent, when using an agent, it tries to read the source code of Vulkan headers, and then it constantly asks you for permission that it needs to access the system, system source code, etc., which kind of suck. So what I'm gonna do, I'm just gonna bring in my own Vulkan headers, and you could basically do that using this library. So Vulkan headers right here, and you're just gonna copy this guy, and then you're gonna say gh, and we're gonna grab a release tag from here, and since this is actually let's just go with the latest Vulkan SDK version, right? So basically these Vulkan SDK ones, these are like the ones that are being used by the latest SDK, so we're gonna go with that one. Why not? And there you go. Next up, what we're gonna add is so usually I would also, for Vulkan projects, I would use the Vulkan memory allocator, but since we're gonna be using what is it called, Skia render, it already actually brings that on with it, so we don't really need it, but here you go, just for reference. Other than that, we're gonna use the Vulkan VK Bootstrap library. So in fact, here there is two libraries. There is like VK Bootstrap, which is a C++ library, and there is Vulk. So Vulk is just a meta loader, and this is loader, and this is the one that most people use because it's just a simple C library that just gives you like load for you all the function pointers from the driver, so you could have a very quick dispatch without going through the loader trampoline, which adds a bit of overhead on every single Vulkan call. So instead of doing that, people use this Vulkan meta loader or loader. And now instead of this, we're actually just going to use this C++ library instead, which is called VK Bootstrap, which does kind of the same thing as Vulk, but it does it in a C++ way first of all, but it adds extra things. It adds easy instance creation, physical device selection, device creation, getting the queues, and the swap chain creation. And it also adds several conveniences too, like enabling the validation layers for you, adding a debug callback messenger, enabling extensions on physical device, and selecting a GPU based on a set of criteria like features. So basically in Vulkan, if you wanted to like filter your devices and queues, etc., you had to do a lot of bookkeeping crap. So like you have to go to tell Vulkan, please enumerate all the devices for me, then enumerate all of its properties, then enumerate all of this and all of that, which really sucked because it's kind of like an imperative way of doing it. You tell it exactly like the steps that you're gonna do. But here using VK Bootstrap, what you do is you just tell it what you want. It's kind of like declarative. So I want this extension, and I want like a physical device that is capable of Vulkan 1.4, etc. Blah blah blah. And it just does that, the extra Vulkan stuff for you, so you don't have to deal with that, right? And yeah, that's why I'm gonna use this VK Bootstrap. Also, swap chain creation is really finicky, honestly, so it really would save you a lot of time and stuff. So yeah, I really recommend this library, which we're gonna actually use in this case. Okay, so this is just a little bit of background. So I keep this as a kind of a great tutorial on why I've done what I've done, right? So Charles Lunar G VK Bootstrap. Next up, we're gonna grab a tag from here, and let's see this tag. So this one was just 3 days ago, so sure, let's go with that. Perfect. So we add these. I mean, you could actually remove these tags or just use the main branch, but this is not great because you want people that would clone your repo would get exactly the same code and versions as you are. So that's why we pin it to these commits. So yeah. All right. So we got VK Bootstrap. What's next? Next up, I think we're also gonna need what else? Let me see my other prototype project. Where is it? That the agent made, third party. So we got the Vulkan headers, the SDL, the Skia, and the VK Bootstrap. So finally, I think we just need Skia. So Skia, on the other hand, is a bit more involved. So for Skia, it doesn't have like a native CMake thing, so we're gonna use another CPM function for that. So let's just quit these for a second. And also this, and let's just leave that for now. Okay, so we're gonna go to the wiki again, I believe, and let's look for the snippets. So I'm gonna show you where you could also find. So for example, let's say you want the Rang library. You're just gonna copy this snippet and you're gonna add it to your project, and boom, it works. But in our case, what we really want here, since we don't have CMake in Skia, we're gonna use a download only one. Well, let's see. At some point we're gonna use Gtest, Google Test too. And by the way, if you want to use add boost, you could just use this too. There you go. So just read about this one. But anyway, we don't need boost, at least for now. All right. So for example, here's an example. For example, Poogie XML. I think maybe it doesn't use like CMake. It actually does, so I'm not sure why they did download only here. Another cool example is Lua. Lua doesn't use CMake either, so you also do download only. So this is what we're gonna do for Skia. So first of all, let's find the Skia GitHub repo. And actually, this is just a mirror, I think. Wait, Skia, bruh. This is just a mirror of their own kind of Google source thing, but it works for us, so that's great. So it's just Google/Skia apparently. Okay, so we're just gonna basically just copy this, and let's see how we're gonna use this. So the name is gonna be obviously Skia, and the Git repository would be, well, Google/Skia. And the version, well, the version, we're probably going to use git tag, but let's see. By the way, also we could actually, another way we could like add Skia, which is through its releases. So for example, here's Sol 2. Instead of downloading the source code then building it, what you could do is you could just use a release archive zip, which is like binaries and just links to those libraries directly. But the problem with this way is that you lose out on the debug symbols and the actual source code. So, and also control over how you're gonna build that thing. Like for example, adding some things, removing some things, disabling some things, etc. Anyways, so what we're gonna do next here? So download only, yeah, cool. Now instead of Lua added, we're gonna call this Skia added. So basically, after you add some package using CPM, you have this Skia added like variable, you know, and then you could basically tell you if it got added or not. So for example, for Lua, they add these sources. I see, and then they remove some sources, and then they wrap it in a library, a static library which have those sources, and then they add the target include directories. So for me, I'm just gonna comment this all out just for reference, and I'm gonna see how I'm gonna do this. In my case, I think I'm gonna use the external project thing that we had got working here in this project. So let's go to my CMake here, and let's see what we got. So there's a lot of sorts of things here, but let's start small. So the external project add, okay. So we're gonna need the source directory, the binary directory, the download command, the update command, the configure command. Can we actually grab like a real example of CMake external project? Because like an official example, kinda. Let's see if there is one. That would be interesting. Because that one was generated by AI, so I'm kind of skeptical. I mean, it works, but I'm just skeptical about it. Alright. Apparently you could also add like a hash to verify the downloads. That's cool. And git repository, get tag, it releases, okay. This is the property, and there you go. Lastly, suppose that provides a script called makedoc, which can be used to generate its own. There we go. Documentation further. Suppose that the script expect the output directory to provide as the only parameter, and that it should be run from the secret sauce source directory, custom step, and the custom target trigger the script. There you go. So the command, the source there, and slash make doc, then the binary directory, then the working directory is this comment, always exclude from main. So this working directory is actually quite interesting. Other than that, let's see what we could do. Let's just see. Fine, let's just see. So here you got like the external, hold on, let me just grab this, and let's see what we're gonna do here. So we got the external project add. So let's just write this by hand so we don't miss out on anything here. So we got like Skia, and though we probably already have this thing, whichever that is, so I'm gonna call this Skia external, fine, just like we had there. And then we're gonna have this source directory. So the source directory is Skia source there, that variable. But in our case, we don't really need to make it a variable, honestly. I'm just gonna put it directly here. So it's basically CMake source directory slash third party slash Skia. But in our case, we're not using get submodules. So we're gonna actually grab the source directory through this variable. Right. Source there, yeah. So we're gonna do it this way. So instead of Lua though, it's gonna be called Skia source there. And I believe that's it. That's the source directory. Next up, the binary directory. So what this binary directory means, Skia binary there. So CMake current binary directory slash Skia dash build. I mean, let's just do the same thing here. I don't really have any particular opinion about that one. So let's just go with that. CMake binary there slash, whoops, slash Skia dash build, and there you go. That's the binary there. The download command, nothing. The update command, nothing. I'm not sure if we really need those, because I think probably if you just left them out, they would just be initialized to that anyways. Anyways, so we'll see. Configure command is, so here like the AI agent had some problems with quotes and stuff, so we kind of did just like stepped over that whole crap and done some few hacks. First of all, it just ran sh directly, and the second what it did, it have gone through the current directory by itself, like manually and stuff, and it even ran the Python 3 stuff manually, which is interesting. But wait, how are we gonna actually be able to? Yeah, we could pretty much do it here. Yeah, we'll see about that. But anyways, I think we're just gonna run for now the Skia source there /bin/gn. But where's the Skia source directory? It's, well, basically this. All right, so let's just copy this part, the configure command, and then what we're gonna do there. So /bin, right? Yeah, it was in bin /gn, and then you basically gen, and then you tell it where you're gonna put the output directory. So here what they did is just add it in Skia binary directory /out/release. Oh, so inside of basically this slash and where's the output there again? Here, so /out/release. Okay. And what they did next is add this --args is equal to, and you basically give it a few args here. And here you shouldn't include these quotes because it breaks CMake for whichever reason. We're just, for now, we're gonna only add this is official build, and we're gonna set it to false. That's all. So basically that official build, if you set it to true, it's gonna give you a release build of Skia. If you set it to false, it's gonna give you a debug release. So that's cool. So in our case, we're gonna say is official build is equal to false. Later on, we may add one of these flags, like for example, to enable something or even to disable stuff to basically take the library size down. But other than that, for now, let's hope that this alone works just fine. Instead of source there, can we just like add the working directory like we did, like they did here, and just use that? How about that? Yeah, I don't know about that. But we could ask the AI actually about that, right? So yeah, in fact, let's ask it. Why not? Sure. Use working their param instead. Let's see what's gonna do. Oh, so I think maybe the working there only accounts for the configure command and possibly also the build command. Is that true? Hold on. So if we look into the working command here, or like working directory, specified to set before running the, yeah, it's just about the commands, not the other paths. Okay. So otherwise it will be set to the CMake current binary directory at the point where I see. So we definitely gotta add that too. It's not required, but better to do that. So we're gonna say working there, and then we're gonna set it to basically Skia source there. And I don't think we need the quotes. The quotes really, you know, really confusing in CMake because it just doesn't have that specific rule, kind of. And actually, why this doesn't... Wait. Oh, actually, it's working directory. All right. So that's why it didn't highlight. In fact, even this didn't highlight, which is quite interesting. But I think it should work. Other than that, what else? So let's check out the other code again now. So that's the configure command, and finally the build command, which is going to be ninja-c, and we're basically going to build the Skia gn output directory. Okay, so where we generated the thing, this guy right here. Okay, so just copy this here. And what else? And then you add this Skia for whichever reason. I'm not sure why they added Skia there. But anyways, the build command, the install command, no. And finally the build products. I'm not sure if that's really required. And the gn output there again. Okay, so honestly this Skia gn output there is really too much. So I'm just gonna, yeah, take these two, really, fine. And let's just add them into a variable because they're used a lot. So, and then what I would do basically is, instead of this, I would just say, so CMake binary, current binary, in fact, okay. And then I wouldn't need this. And next up, this stays the same. The configure command, on the other hand, though, you gotta use probably this guy instead of this. And again, the same thing with this guy here. And there you go. Install command, the build py. I'm not sure if this build py products thing is necessary. Like if we go back to the documentation, by products, added inversion. So you know what I'm gonna do? I'm gonna add the documentation. I'm gonna add this guy, and is specifying byproducts would be helpful or even required. Because CMake doesn't natively peek inside the build command, it has no idea what files the external is actually going to produce. Yeah, I think maybe this is the problem that I had in the previous video, which were it was constantly complaining about it couldn't find that libskia, but although the external project would have built it by the time it reached the build command, but it was checking for it, I think, in the configure stage of CMake. But yeah, there you go. So declaring byproduct, tell Ninja, hey, trust me, this external command will eventually spit out these files. Yeah. And wait a second, what the heck it's doing here? Hold on. Ooh, crap, wait a second. So there is the CMake static. So the thing is about the CMake thing that we've made in the previous video is that we were hard coding this extension, this suffix of the library, which is .a, which obviously won't work on other platforms like Windows, which uses, I believe, .lib and other stuff. So in Linux, it's .a, I think. But apparently there's this CMake static library suffix, I think. There you go. Okay, so that's cool. Yeah, that's pretty cool. So Skia GN output there. Sure, I mean, let's just honestly, what can I say? Yeah, fine. Let's just grab this variable here, put it here, and just use it by products. And I think that should do the trick here. The next step is linking it. So you just add a static imported global, and then you add the dependencies, Skia external, and then you set the target properties. All right, so honestly, yeah, fine, whichever. So here we just wrap the external project, files. Wait, in a CMake target. So add the dependencies. So we basically make sure that Skia external, like to build Skia target. And honestly, for Skia, I'm just gonna do this. I'm gonna call it like this. There you go. Add dependencies, Skia external, properties imported location. And then interface include directories is that. Honestly, for the include, Skia usually doesn't include the whole thing, but fine for now, I think. And yeah, now obviously before we even, I think, add the external project, or is it after or what? Yeah, beforehand, after we grab the actual source code, we need to find the package CMake, Python, and then yeah, okay. So how are we gonna do that? Well, we're gonna say find package, right? And we're gonna say Python 3, and components would be interpreter, and I believe we should add required too. And after making sure that Python 3 exists on the system, and wait, target include directories. Oh, we could actually use target include directories. Instead of target properties, I think there is a modern way to do it, like you still need to CMake where the physical binary lives. Yeah, so at least for the include directories, we could do that. So like this, but we still need apparently the properties thing. Target Skia. Well, Skia like this. And instead of this, apparently we could just say this, property imported location. And yeah, why I don't need the build interface here. I see. All right, so I think that's basically it. Now, after finding the package, we need to make sure to run the Python. And apparently, yeah, how do you run the Python? So tools, I think it was execute command, right? So execute command or execute process. I think it's execute process, right? And then I believe you got like a command. And honestly, at this point, I'm going to remove this commented things. I'm going to give it to the AI, so it would kind of continue. Where is that? There you go. Continue the execute process command. Let's see what it's going to do. And yeah, so instead of Python 3 executable like that, I believe we can probably just use, what is it called, Python interpreter target. Let's see what it's gonna do. Command error is fatal any. Interesting. Oh, okay, so apparently those are actually necessary. So we added them after apparently the working directory, I think. Fine. And he also added this stamp there about missing folders. What does that even mean? Yeah, we'll ask about that actually. Other than that, that seems Skia headers are split across multiple directories in there. No, what the heck, bro? No. Alright, cool. And there you go. But that seems too much for target file. Interesting. But okay, let's just grab that, I think. And the working directory to Skia source there, sure. And yeah. Alright, I think that's good. That's enough. Probably. So I don't know if this would work. I guess we'll find out now. But that would be very interesting. And finally, what we're gonna do is target link libraries. Chaco web to privately to who? We're gonna basically to SDL, Vulkan headers. Actually, we're gonna start with the Vulkan headers first. Then go to VK Bootstrap, then Vulkan headers, etc. Right? Well, sorry, SDL, right? Anyways, we're gonna say Vulkan headers like this, and the next thing is SDL, I believe, or isn't it? Yeah, sure, why not? SDL3, and then VK Bootstrap. I'm not sure the exact target of VK Bootstrap, but I'm just gonna go with kind of like the usual one, and if it complains, I'm gonna basically like fix that. The next thing is finally Skia, I think, right? Yeah, and here we're gonna use our Skia target that we have made ourselves, which is this, which basically just wraps these paths, essentially. And yeah, I believe that's that should be it. And yeah, let's find out. This is what I got so far. What is that stamp there? Oh. Okay. Well, that's interesting. Now it's cloning Skia. So if everything goes into plan, anybody should be able to just clone this repo, do nothing, no git submodules, no Python, no Python, but like they don't have to run the command themselves and stuff, and it would just work, right? So it would just build, which is very unusual to big projects with a lot of dependencies in C++ and CMake. You usually have to clone the module, then maybe configure VC package or configure the submodules or whatever, or run like Python commands, etc., especially with Skia. So yeah, it's good to take some time. Now I could have just like, you know, copied that code over, but that would suck because I wouldn't understand, like wouldn't learn much. But yeah. Yeah, I think last time in the previous video when I was really struggling with Skia, I was probably just missing this byproducts argument. And so Ninja couldn't realize that this external project is the one that's going to basically build that library that other people are. And hold on, failed to check out the tag. Oh, I think I probably missed. Yeah, I see. Hold on a second. Mirrored from. Right, so there's some tags here. And hello, Federal. Welcome to live stream. Wait, hey, elbow, hey. So like YouTube, for whatever reason, it auto translates, and it translated hey Kodo to hey elbow. I don't know why. I'm not sure what even that like language it tried to translate from, honestly. But anyways, so yeah, I forgot to update the Skia version, and here's the versions they have here. One is from April 10, which is, I believe, fine. But like, there's one for PathKit and CanvasKit. What? Wait. I mean, I understand what's up with these CanvasKits ones, but like, wait. Are you building it from scratch or using an existing language? An existing language? Lazy Sully, welcome to the live stream. Well, obviously I'm using an existing language, C++. Building it from scratch depends on your definition of from scratch. I am going to be building it from scratch in the sense that I'm not going to be using an engine or a framework, but I'm going to be using heavily existing open source libraries. In fact, I want to try as much as possible to delegate a lot of the tasks to existing open source libraries. For example, rendering, instead of doing it from scratch, we're going to be pulling in Skia, but obviously we're going to be gluing everything together, and we're still going to have full control over the whole thing. Let's build in script. Okay, so well. All right, so should I use PathKit version or CanvasKit? Because I'm not sure what's the difference there. Neither. What? Hello, Karim Biazit. Welcome to live stream. That's very strange. So in this case, you know what I'm gonna do? I'm just gonna grab the last git commit and call it a day. Okay, so I'm just gonna grab that, and yeah. Where's that CPM thing? All right, here. Oh, I actually tried to use the version. I think right here I could probably just say git tag. Sorry, yeah, I think git tag or git commit. Wait a second. If we go back to the snippets here, yeah, there you go. So git tag, and you could use the commit here. So that's great. So this is if you don't find a good release tag, then you just use the latest git commit and call it a day. That's all. And I think that's the only problem we had. And honestly, before even that, another thing that I forgot about, which is like setting the wait, what is it called? So yeah, setting the thing, where is it? In fact, there you go. I think this variable probably. Let me just make sure. There you go. To avoid redownloading dependencies, this can be passed to CMake as the, yeah. Give me a force CMake cache line to set in CMake. I don't know if that makes sense, but let's see what it's gonna do. Right before you download or include cpm.cmake. Okay. And it's just gonna set it to the NV environment. No, no, not NV home, just the current directory. Let me actually describe exactly what I'm trying to do here. CMake current source there, okay? .cpm-cache. So we're gonna do this before we download the CPM. So here. Yeah, and obviously you need to make sure to add this force and cache and this bullcrap of CMake to make sure, because like sometimes, so basically override the cache, the CMake cache, because otherwise it could not work. But yeah. All right, so right now it's probably gonna re-download everything, and that's fine, I think, because we haven't like downloaded Skia. Actually, we probably did, but at least we didn't run the other stuff. And can I actually view their hidden folders and stuff? Well, let's see. How do you see the hidden files? Bro. I remember there was like an option. More view. Oh yeah. Show hidden files. Control H apparently. Okay, there you go. And here we got a CPM cache. Now why I did this. So this is the problem that I had with the fetch contents, is the fact that when I remove my build because something broke or whatever, I lose my downloads again, so we have to also re-download everything again. So here I set that variable to .cpm cache folder here, so it kind of separates my downloads from my build stuff, build binaries. But yeah, and it seems to be still going fine, I guess. And boom, abnormal exit with child return apparently. No such file directory. Let's see what the AI would say about that. I could fire up the agent and it would just like debug the thing itself, but another thing that I also gotta make sure to add, just so I have an idea of what's going on, is there is some variables in here, and I'm not sure why it's not the default. That's so stupid. But there is some terminal variables there that would make sure to give me the progress. There you go. Use terminal, configure, and you just set it to on, I believe, and use terminal build. Gonna set it to on. So it would tell me the progress of both configuring and building. Wait, configure. Yeah. And that's cool. Alright, let's go back and see what's up here. Okay. Literally reads the raw. Okay. Yeah, I really wanted to use that target thing, but whatever, I don't care. Just do it, dude. Where is it? There you go. Yeah, let's just use this normal thing, because I've seen before that there was a way to use the target, but whatever. And okay, what's going on now? Don't tell me I have to set something in the execute process so it tells me the messages there too. I don't think so. Last time I think it tried it, it didn't need anything. And why the heck it keep on? You appear to have cloned an empty repository. Bro, what? Something is strange going on here. Oh, what? Did Google seriously, like, you know, just I'm not sure what the heck is going on. Hold on. Stop this crap. Hold on. Did I not intentionally, like, wait? Bruh. By default, git sync dep spawn, which is a trigger, you can force it to run. Bro. I don't know if that's even an actual argument there, but let's try again. And why the heck my computer is going insane right now? Wait, what is it called? System monitor? Right. Let's actually pin it to the task manager, whichever. I don't know what the heck was happening there. Anyways, so what are we gonna do now? We added that G1. Yeah, I think let's try again. By the way, the live stream is fine, right? Yeah. Okay, let's just try this out again. And notice that it doesn't try to redownload everything again, which would have sucked real badly. And let's see. problem is, it doesn't tell me much about what the heck it's doing. I think right now it's working. Though it's definitely, I think, taking years. Maybe. What the hell? A known CMake command. Hold on a second. Oh my, I hate the IDE, bro. Wait. It's trying to analyze the project and it just lagged the whole thing. Bro. Wait, we're gonna do this. Can I? Or yeah, fine, let's just do it normally. Fine, let's just do this. Can I crank up the memory? What's your recommended value? Though it doesn't really need it, I should find somehow to like tell C-line to not, you know, analyze the dependencies of Skia, because that's what's causing the slowdown. But yeah. Yeah, fine, let's go with this one. Come on, bro. Why it is setting it to 2000 at first? But I'm gonna stop it from analyzing everything. Hold on. Or maybe I could try to tell it exactly what to do here really quickly if possible. Yeah, stop that. And I'm gonna go to its dependencies. Where's the dependencies? Hold on. Not bin. Okay, where I put that stuff? Hold on. I think third party. There you go. Okay, so I'm gonna do this. All right, so I'm gonna say mark directory as excluded, and I'm gonna actually just restart the IDE, because I'm not sure if I resume that thing, would it take into account that excluded folder or not. So I'm just gonna restart the whole thing and call it a day. And then we should have no problem anymore, because what's really slowing down the IDE is that it tries to basically index the whole Skia, and it also includes all of its dependencies, and it just slows everything down so badly. So yeah. And now let's hope it works, but Other than that, we did have some problem with CMake project add for some reason, which is strange. Oh, okay, my bad. Alright, so we're just gonna include this guy really quickly here, and let's try to reconfigure. I think it works now. I guess. Boom, no. Something happened wrong. Oh, libm. Maybe I know what's going on there. And does this guy know about my current CMake? Or you know what, let's just feed it that, fine. Alright. No, it didn't take into a... Wait, what? Oh, I see. It didn't actually ran my thing, for whichever reason. Alright, fine. I don't know why that's the case, but let's just remove that work in there thing. And did it really change anything much there? I don't think. Yeah, I don't think so. Alright, let's just reload the CMake again. And let's try again. Bro, what? Oh, the first error, in fact, I could not find the GL file. Maybe I should first check, now could I check what's next? Check. Hashi, welcome to live stream. No, it was actually codes otaku. And then I kind of merged these two words together and became code otaku. Yeah, that's the evolution there. I think what I'm gonna probably do here is just reset the cache and reload the project. Luckily though, it wouldn't have to reload that stuff. And let's see. What are you trying to make? Trying to make a web browser, but we're still dealing with the dependencies first. And welcome to the live stream, PC Coder. And boom. You know what? Let's just make a new chat here and let's see what's up. Or I could fire up an agent to debug this thing, honestly. Bro, what? I mean, I guess let's try. So we're gonna do -- root and let's just try it out, fine. See if that would fix anything. Oh, it actually compiling Skia now. Sick. Hello A1234ABC. Wa alaikum assalam. So it actually like auto translated it. And right now it's actually compiling when I added that -root thing, which is interesting. On another note, this worked too. Generated previously by an agent. It didn't need the root argument though, for some reason. Oh yeah, it uses CD. I see. Gotcha. You have the code on GitHub. I definitely would open source this, and we could like everybody could work on it too. But yeah, I'll definitely open source this at some point. But you know, it's just starting. I'm just like making the CMake thing right here. Will the project be fully made with AI or partially? No, just partially. We just would use AI to assist us. And like prototype and stuff, but like it would be all written by hand. Instead of building Skia, you can use Skia EUR package, but that's problematic because not everybody have Arch Linux, and like for example on Windows, for example, what you gonna do for that? You can't. That's the first thing. Second thing, we would have to depend on the exact version of the system Skia, and also its own build flags, etc. So like, if the Skia system command, system library doesn't include a specific feature we want, then it wouldn't work. Another thing also is, if you want to build the whole project as a static binary, you can't do that easily. Well, you can't actually do that really using that. The other problem also is debugging. If you wanted to debug and enter inside the Skia source code to see what it's doing, then you can't do that. Another thing is, if you want the agent to debug the code, if it doesn't have the source code here, it wouldn't figure it out. Like it can't do that essentially. And yeah. So right here we built a whole one CMake script that literally does everything. It downloads CPM for you. You just have to have like a CMake, Ninja, and Python on your system, and it would and Git obviously, and it would do the rest for me. Yeah, so many reasons. Yeah, because like I've gone through this a lot, right? Like I basically try a lot of ways, and I figure out why I shouldn't do that way. And yeah, because like I experiment a lot, which really takes out a lot of my time, but at the end of the day you come up with cool solutions. Yeah. But at the end of this, we will have a pretty good, well, hold on, what the heck? No rule to make the target stuff, install stuff. Maybe we should say install command, I believe. Are you gonna use the features it has to offer? I mean, not necessarily, but we'll see. Like if there is some feature that we found through the AI or whatever that it could use from C++26 and it is supported by my compiler, then we're gonna go with it. But I'm not gonna go out of my way to try to, you know, search and like literally use everything C++26 has to offer. But if there is a specific feature from there that we could make use of, then we're gonna do that. Okay. I think probably just because of the install command. But let's see what the AI would say. Come on, why it just lagged out here? Bro, come on. Yeah, it's super slow. And actually wouldn't work for us. Anyways, let's just say this, fine. Because Skia used and said there's no make this song, I just need to tell. Yeah. There you go. So we need this too apparently. Okay. Actually, we do already have that. What the? Nah, I just added it. My bad. Okay, fine. Let's just reconfigure and try again. And let's go. Alright, so at least it compiled now with no problems. And now the real thing is, does it able to use Skia or not? Obviously we do have SDL now, sick. But do we have Skia stuff? Bro, what? What are the Skia headers called, bro? Where's the include? Include. There you go. There you go. Okay, so we already got that stuff. Nice. Okay, where's the raster stuff? Let's try with just raster for now. Let's see. So where we could find a raster? Obviously not the GPU though. Not SVG. The encode. So there is some encoders which we could use to like encode an image into. I think it's probably about the surfaces, but where we could find the surfaces? I think core. Yeah, probably core. And in core we have all sorts of cool things. And let's see, core SK surface, I think. There you go, sick. So that's that. And if we actually, we could look into the structure here. Yeah, there's all sorts of things here. SK surface, right pixels. I wonder if I could remember how to do this. Let's see. There is this raster thing. There you go. I see. So I think that's probably just for mocking. You like make a null surface there, but yeah. And here for the raster, you give it like this image info. Well, in fact, there is two of these. There's this guy, and then there's this guy. Yeah, we could just use this guy. We don't have any particular row bytes, I believe. So this allocates a raster SK surface. SK canvas returned by SK surface draws directly into these allocated pixels. Return draws directly into those allocated, which are zeroed before use. Pixel memory size is image info.height times the minimum row bytes or row bytes to provide a non-zero. Okay, well. In fact, you know what? We could do something interesting. I'm going to show you in a second. But for now, let's just try to make something very simple. Info are greater than 0. Contains SK color type supported by raster surface. Okay, let's just try this out. Fine. So we don't need any of that BS. And let's see. So basically you could say SK surface, and I don't like the JetBrains inline stuff. Yeah, it really sucks. So I'm gonna actually just remove it. Thank you. And let's go. So surface, and you basically give it what? You give it the width and the height. So in my case, let's say, for example, 800, 600. And then you give it the SK surface props. Well, I believe there was an SK image info instead. Actually, let's go with the SK image info instead. Fine. I'm not sure which kind of, but anyways. So SK image. Oh, do I need to like include that or something? Bro, what? Why can't make SK image info? Really? That's weird. Maybe you could try and make use of the grep here really quickly. So I've seen CPM cache, so CPM cache, and how you do it exactly. I think like SK image info, or whoops, I think it's probably the opposite actually, isn't it? Hold on. CPM cache, bro. Recursive flag, header, it's inside core. Yeah, maybe we should do that include thing that it was talking about beforehand. Oh wait, actually, well, it is including it here, but what the heck? Anyways, let's just grab that thing and let's see what's up. And it's taking years. What the heck? Really? Yeah, no. For some reason, wait. In fact, you know what? I'm gonna do this. I can't define the SK image info struct for some reason. Or my includes wrong or something. Because it did say something about that. Yeah, so like SK core, SK image info. But why it doesn't exist there? Oh, there you go. What? Bro, really? Okay, fine, whichever. I mean, like CLine is supposed to tell me where that exists, but it didn't. But whatever. Anyways, at least this works now. So, all right. So here you got like the SK dimensions, sky size. Can I just do something like this? Can I? Or do I have to like just set it like this? Okay, fine. I guess you set maybe the width, or wait. Let me just see how this goes. Hold on. So describes the pixel dimensions and encodings. Oh, there is actually a make function here, which is sick. Oh yeah, make int32. In fact, there was like int32 pre-multiplied. I see. That's the one that was used. Okay. int32. Make unknown. Okay, let's go with that one actually. So how do you do that? Well, I think probably like SK image info make n32 pre-multiplied, and then you just give it like the width and the height, which let's say for example is number 32. Okay, and we could just say auto image info is equal to that, and let's call it a day. Is that true? What? Why it's not allowing me to do that? Yeah, I believe I see. I think I know what's up. I think I know exactly what's up here. So yeah, Skia doesn't use this kind of thing. So yeah, you know what? Let's just try this again and see, because I think that's probably the problem here. I'm gonna reconfigure, and let's try again now. And obviously right now we gotta make sure to say include slash ourselves too. And I believe now it would work. And let's just remove this for a second here. Okay, boom. So that got fixed. Okay, so now let's figure out the rest. So the SK surface here, what it requires, obviously an image info. And can I maybe say null PTR here for the surface props, or do I have to make it? Oh, the surface is abstract. Interesting. Is there like some static function that you could use? There is a make surface function. All right, and there's even a temporary image. All right, let's go with the make surface function here. And then you just give it like the image info apparently. So, or null PTR. All right, is that good? All right, and now what's up? And honestly, another extension that I like, or plugin that I like to use here is, what is it called? I think lens, air lens, or info lens. Yeah, inspection lens, it's called. And boom. So this is actually a method. All right, you know what? Why this doesn't work? Call it a day, let's see. Come on. Oh yeah, so you see SK surfaces not even. Alright. Yeah. So when I generated that using the agent, I didn't really pay attention to that actually. So you use this raster function. And then you give it the image info. And you could also give it the row bytes and the surface props. In our case, I think we could probably just give it the image info. All right, so now we got a surface, perfect. And if the surface is null PTR, I would guess it have failed, or isn't it? In fact, it gives an SKSP thing. But I would guess it just works the same way, so we could just say if not surface. Then, I don't know, let's just return. And yeah, for now. And next step, what we're gonna do is, good question. I think we can grab the canvas now from the surface, right? Yeah. And then you could basically use the canvas to draw stuff, isn't it? What? I'm confused. Get canvas. In fact, you know what? We could go to the documentation of Skia, my bad. I think there's probably some examples there. And while, yeah, we could use the AI, but it's better to understand what the heck we're doing. Yeah, why the hell? I think because we're probably not, yeah, I think so. That's probably the problem here. We need to include, I think SK canvas. Maybe that's the problem here. Is that true? There you go. So to actually get these methods, you have to include that to, like, yeah. Gotcha. So to clear something, you can make an SK color. So either SK color or SK color for F, apparently. How about for F here? And apparently you could say from RGBA and from color. I mean, how they do it here? They just use those constants. Fine, let's use those constants. So SK color white. There you go. And or even let's go actually with red. Fine. And can we just like save this canvas now? So yeah, you just do the drawing stuff, and I believe you're done with the drawing part. Right now, would they say how to use that? I believe you just say, I guess, surface save snapshot, I believe, or something. Yeah, there you go. So make image snapshot, and let's go, and then you grab an image out of that. Now you're supposed to like use some encoder, some PNG encoder. And I believe those we could find them in the encoder. So include codec or wait, what? There's a decoder. There you go, escape PNG encoder, and I believe just make one of the yeah. So how does this work exactly? Oh, they're just, I guess. All right, so you use the encode, I believe here. But is this inside of something? Yeah, inside of the SKPNG. Okay, fine. So I think you say SKPNG encoder, and then you got encode, and there's even make. I'm not sure what it is. That will encode the source pixels to the DST stream, or whatever. Let's just go with the encode function here. And you could give it a context, which is no PTR because we're not using the GPU here, we're just using raster. And then the image that you want to save, and finally some options, which I'm not sure what those options are about. Let me see. Yeah, they just contain some extra stuff. So, and they do have defaults probably. So can we just say maybe this? No, apparently not. And yeah, let's just say SKPNG encoder options, and let's see what's up. Is there a way to it doesn't really say. Okay, let's ask the AI really quickly. How do you make those options? So you just do this. Okay, fine. All right, and let's just pass in the options here. And now what's up? Oh, so that was the actual, I see. Because this takes in a raw pointer. Gotcha. And like this SK, whichever that is, wait. The SKSP is like a smart pointer of Skia, I believe, or like at least reference count, I think. But yeah, so basically you use it to, let's say, control, for example, the compression level, etc. of how you're gonna save that stuff, apparently. Why would you need the stream? We'll see about that. Alright, fine. What this encode returns, in fact? It returns for you the SK data. But from what I've seen there, I guess you could say encode. Okay, so you could give it the stream, or you could use this guy to grab the data. Okay, I see. So like if you grab the data first, then you kind of need to basically allocate some place for it, then you write it to the stream. But if you use their stream here, their file stream, you could directly like encode the image and directly write it to the file without having to go through a buffer, essentially. So yeah, that's actually better. So sk file w. But either way, let's say we actually have used this, how this works. So it basically gives you this sk data. So holds a data buffer. It can be created to allocate its own buffer for the content or share pointer to the client's buffer. Yeah, so you could grab just the data to the pointer, pointer to the data, and then the size, and then you could do whatever you want, or just like bytes here, right? Or even a span. Okay, so that's even better. An sk span. It's kind of like std span apparently, and then you could use that. But let's just use that. Fine. Let's use the sk stream thing. SKW stream, so I guess that means write stream. Is that true? Ah, I see. So like when you include that thing, it just uses the forward declarations here, which doesn't have any thoughts about how that works. That's why that happened before. So I need to find where that stream exists here. And I would guess it's probably in the stream, skstream.h, yep. And then you could basically create a stream here. Is that true? skw stream. Didn't it actually, wait. Oh, it's actually a sk file. Whatever. Alright, let's just use it. sk file. File. So there is two. There is file stream and file w stream. What's the the difference here? I have a lot of questions. Where is it? The other one? Oh, so it's for read stream. I see. So it's basically their versions of std off stream and f stream. So that's basically the case here. I see. So essentially, if this stream is valid, then we could go ahead and encode the image into that stream directly without having to go through a temporary buffer. And for that you gotta pass in, I believe, the stream here. Well, let me see exactly what it is. Encode, and then I believe you give it a stream. But then you gotta give it a pix map apparently. Yeah, but why that didn't work? Or maybe I could just give it like image directly or what? And obviously we don't really need this. And if I actually do this, it doesn't work either. Why this doesn't work? Or maybe I should use something else. Oh, wait. Do you really need to like make a codec first? By value? No, I don't think that's the problem here. I mean, actually that's one of the problems, true. But the other problem is I mean, let me give it the error really. Come on. But I want to understand what is that pix map using pic pixels. Okay, so you basically create this SK pix map, right? And then obviously you say if image pic pixels, all right. Copies the SK image pixel address. I mean, okay. Then we're gonna encode, and instead of image get, I believe you just pass in the pix map. And yeah, that seems to work, I guess. And sure, move that. And yeah, I believe that's probably it. There you go. Doesn't work on GPU backend. Use solution 2 if you ever switch to GPU accelerator. Okay. Alright, let's try this. And we should get like an 800, 600. Wait, what the heck? And just in case, well, actually I can't give it everything apparently. Alright, whichever, let's see. Really? I think it does include free type already. So, or maybe we're supposed to like enable it in the arguments and then it would work. Or actually, let's ask it. Doesn't Skia already include free type into its third-party dependencies? Or do I need to maybe enable some flag? You know, first of all, let's just use this little fix, you know, just temporarily and see how it goes. And then we're gonna investigate that. So how are we gonna do this? Target link libraries, free type. Alright, so I'm on Linux, so this would work for me because I definitely, at least I think so, I do have free type library. And let's just include this. And it worked now. Alright, so I thought my CMake system was broken somehow, which would have sucked so badly, but apparently it seems good. Now where did it put that image or whatever? That's the real question. Oh yeah. Alright, so as you can see, we got an image here. Which is great, which means our Skia setup is working out just fine, which is lovely. And I think it's probably statically building everything, because like my Kodatek web, it's like 78 megabytes for whichever reason, though obviously it does include all the debug symbols of both Skia and my application, etc. But yeah, so right now at least I kind of figured out that it does work. But I think let's try to fix it the right way by including another argument here. Right, so yeah, it works with free type, but I want Skia to include it by itself. And let's see what's going to say. But it's good to know that I could actually like just set up free type myself and make Skia use it possibly, but anyways. Right, equal false. So I guess I could say this apparently. Alright, and if I remove this now, so basically we do this to kind of like escape the space, so it is included in the arguments kinda. But let's just see what's gonna happen here. If it's gonna work or not. Maybe you should try to yeah, I think that's probably broken. Yeah, I think you don't really need that. Yeah, I don't think, like, let's say just this, just that. Let's see. Wait, let's just reload CMake here. Yeah, no, but what if we do it then the way it did it, like here, in this. No. I'm not sure how the agent like fixed it before. That's the problem with using the agent, you don't really know. It actually said free type equal to false. Yeah, I'm not sure why it didn't ask me for free type there. That's because like here I'm not using any text stuff, so it doesn't even actually need it, in fact, which is interesting. Right. Yeah, you see CMake have a lot of weird quirks. You don't know if you need to use like quotes or not. It's just so freaking annoying. Bro, wait, what? So I guess I still need to do this, although it's not using the system free type. Huh. Or maybe I should just actually say just that. That's weird. I mean, this worked. If it linked to I don't want to use the free type of this. My God. But the agent didn't need, or did it? At least I think so. I mean, let me see. CMake list. Yeah, that's the only thing that it used. Worked just fine. I just want to iron this out. I could have just used the system library. Okay. I didn't notice that. So it just said Skia use free type equal to false and called it a day. I mean, obviously at some point we may need like free type, but right now, bruh, I I don't want anything to do with this. Alright, let's go back to, where is the CMake? Okay, here. So I guess use Skia, use free type equal to false, and then maybe it would work, because we're not really using free type right now. Why it's recompiling the whole thing, bro? What? Yeah, it's compiling 550 files. Crap. Or units. And yeah, now it worked without free type. All right. Yeah, that was interesting. Okay. Well, all right. Okay. Well, I think right now let's just go to the SDL stuff right now and hook this up again. So fine. Alright, so now that we got Skia working after all that business, how much it took to make sure that everything is well with the CMake stuff? Okay, 2 hours already. But anyways, so here we're gonna define what? We're gonna define the SDL main callbacks straight out of the gate. Why not? You're just gonna search for the main callbacks, main use callbacks, and you're just gonna define this. There you go. And then we're gonna go to this readme, and we're just gonna copy that app init, boom, the app iterate, boom, app event, let's go, and the app quit, and let's go. Now what we're gonna do is include SDL app main, bro, SDL main, and now, and we're also gonna have like some sort of like struct app for now. And okay, and why not, let's just use the like the trailing thing, and this. Now what we're gonna do is we're gonna create a unique pointer from the app. We could just allocate with new, but well. And another thing is that the app should have like an init function, and like obviously auto init, and it would basically grab an std span of what? Yeah, of char. So that's the arguments, and it would basically return SDL app result. And we're gonna do something similar with iterate here. So for the iterate, you're just gonna return SDL app result, and we're done. And for the event, there you go, app result, and the quit. So for the quit, it's gonna grab this guy, although we're not using it currently, but fine. Let's just and also this event here, and yeah, and we're good to go. So, and for this guy, we're just gonna say void, and we're good. Now for the init, what it's gonna do, it's gonna create a unique PTR Wait, no, not here, my bad. Here in the app init function here, we're gonna say std, or I think auto app is equal to std make unique, and you're gonna make unique the application, and you're gonna give it like an std span of argc comma argv. Actually the opposite, argv and then argc. Though you gotta better static cast that into an integer, I think. Narrowing conversion. What? Cannot convert int to parameter type long int sign. Yeah, sorry, size t, not int, I think. Cannot initialize type with parenthesized. Really? Oh, it should be the constructor. Alright, well, we're not going to be using the constructor, sorry. I forgot about that. But we could grab that, and then we're going to grab the result is equal to app init. And then you give it that constructor here. And since we're doing that static cast, we don't even need that std span there. And next up, what we're going to do, we're going to say app app state is equal to what? To app, and then we're going to release the unique pointer so it doesn't destroy on this scope end because we still need it. And after that, we're just going to return back the result of the initialization here. And we're pretty much done. And honestly, I don't really want to care about this const. It's just annoying and it doesn't really add anything to the mix. It's just so freaking annoying. And other than that, I think we're good. Next step, what we want to do here is just grab the app. So like app is equal to app state, and wait, well, I guess then can we static cast that? Fine. And since we're using static cast, we could just say auto app, and then finally we're gonna return here app iterate. There, let's go. And we're gonna do similar things for the app event here. And we're gonna pass in the event. So here basically we're just allocating an application. We're initializing it using the argc and argv, and then we're releasing the allocation, the ownership, to the app state pointer, and we're storing it in this app state void pointer that is coming from C, from the SDL side. And so that pointer is given to us in the other SDL callbacks too, and then we're basically just casting it to the right type from void pointer. And then we're just calling the existing methods. And yeah, cool. Next up, we just say app quit, isn't it? Well, obviously we got to do this first, and then we can say app quit, and then add in the result there, and you're good to go. And honestly, I'm gonna tell it to not bother me with this one too, and let's go. Now what we're gonna do next here is currently we're just gonna say return SDL app continue, and we're gonna pretty much do the same thing in here. And for the this guy, we're gonna switch on the event type. Well, how do you do that? Well, there you go. And then we're gonna say case SDL event quit. Then we're gonna just return success. Otherwise, the default case, we're gonna return SDL app continue. That's the event part. Now the quit, we're not gonna really do anything, and let me take care of some of these stupid inspections that are really annoying. I don't give a crap, come on. Let's just disable this inspection, and Disable this inspection too. Not your business. Let's go. And yeah, there you go. So now we have something going. All right, so let's try to create a window though. Let's see if this code works first of all. And yes, it does work. So now we're going to create a window and then use Vulkan, etc. In fact, let's start by Vulkan, I believe, maybe. Or the window. Where's the application? There you go. Okay, so what we're going to do here is... Alright, good question. Yeah, let's just put it here, fine. SDL window. And in fact, for the constructor, I'm just going to tell it to initialize everything to default. How do you do that? I think you probably do it this way, right? Yeah. And then what we could basically do is that the window is equal to SDL create window. Right, and then for the tile, we're going to go with Kodochaku web. The width and the height, let's just go with 800 and 600 for now. And for the flags, we're going to go with Vulkan. And then an SDL like other than Vulkan, what we have? Resizable. And also I'm gonna make sure that it's hidden by default. And let's go. Now we're gonna create a little error checking helper here, and we're actually gonna be using a little bit of a modern feature, not much, but still. So we're gonna call this so like check SDL, I think. And what this would take is an actually a Boolean result, right? And then a source location or lock, which is going to be like a CD source location. So instead of basically creating a macro, we have this source location thing that we could use, which is very handy. You're going to see in a second how that works. And for the lock here, what we're going to do is std. I think it's just this, probably, or like just this actually, in fact, yeah. So you're gonna make sure to give it a default value right there, and then it's gonna instantiate it by itself. Okay, so what are we gonna do next? So if not result, then you're gonna use the SDL log error. And then we're gonna say SDL log category error. And next step, we're going to say the format. So the format would be the file name, then the line, and then the colon, and then the actual error that happened. Now, in this case, what we're going to say is lock.filename, and then lock.line, then lock.column. And then the actual error, which is SDL get error. If we really want to be fancy too, we could even add in the function name too, and then we could just say function name here, comma, and let's go. Just make sure one thing is that the file name and the log line and the column are both like this in this format. So you like cline, for example, would give you a hyperlink. If you click that in the terminal, it would get you straight to that specific part, to that specific line of code where the error happened. Other than that, I think I'm just gonna go with exit to keep things very simple here. And I'm gonna go with one status. And let's go. And that's basically how it works. Now here, what you would say is check SDL window, and boom. Next up, you also, after you're done, you gotta make sure to show the window. So SDL show the window, and let's go. Now, before even that, what we really want to do is SDL init, obviously, but we're gonna use the check SDL here. So SDL init. For now, we're gonna go with just init video, and You could even call, I believe, something called, wait, set app metadata if you want. That's useful in some platforms. And yeah, let's just call this code Taco Web, I think, and the app version would be, I don't know, like this, and then the app identifier would be com.codeotaco.web, I guess. Fine. And obviously you gotta make sure to check SDL. So this is useful in some app platforms, I think probably like Mac, for example, but whichever. Other than that, what we're gonna do next is making sure to load SDL Vulkan. Load library, and let's include the header it needs, which is SDL Vulkan. And here it's gonna go with null PTR basically. Next up, after that we're gonna grab the vk proc or whatever you want to call that, and let's see. So like vk get instance proc EDDR, there you go. And we're just gonna make sure that that's, yeah, because that could be null for whichever reason. It's very unlikely, but you know, just to be pedantic here, let's just do it. Next up, we could say that vk get instance proc EDDR is basically equal to vk proc static cast and pfn vk get instance proc EDDR. Maybe it needs actually a reinterpret cast instead of a static cast, but I'm not sure. But for that, what we're gonna do, we're gonna include Vulkan. But before we include Vulkan, we gotta make sure to have vk no prototypes. Actually, not even, I don't know, we'll see. Vk no prototypes, like that, just to make sure it doesn't include any prototype, function prototype, only the function types. And then we could include Vulkan first before everything. Next up, yeah, I think we're good now. Yeah, you need to use reinterpret cast for this. And there you go. Now next up, we're gonna be trying to use the, what is it called, vk bootstrap. And how we're gonna use that? Well, why I don't have vk bootstrap? Bro, what? Oh yeah, so it's written like this apparently. Cool. vk bootstrap.h, and what we're gonna do next is basically create an instance builder apparently. So like an instance builder. Oh, okay. vkb instance builder, and let's see what we got here. So can we set the what is it called? Yeah, good question. Because the thing is, SDL takes care of loading the library for us, and I hope there is something for that in the instance builder or whatever, and vk bootstrap in general, like some way to use that. Okay, let me ask AI here. Is there a way to give vk bootstrap a custom vk get proc EDDR that I got from SDL 3 Vulkan load library or load. It's not really necessary. It would work without this, but you know, just to make sure that SDL is using whichever it needs to use, I think. But we'll see. System info, really? Is that true? Oh, there you go. There you go. Nice. Alrighty, lovely. Okay, so what we're gonna do next is let's go back to VK Bootstrap and see what's up here. So here they're just setting the application name and requesting the validation layers using the debug messenger, blah blah blah. Okay. So here we could just say instance builder dot set. I mean, fine, I guess. Request, okay. Request validation layers. Then we could say request a specific like version. Let's go with 1.4. Then finally we build that thing. Now obviously it would be better this way, this way, this way. Now other than that, we can also use the default debug messenger. Sometimes it uses use, sometimes it uses require. It's kind of annoying, honestly. But anyways, what's going on here? Anyway, so how are we gonna do this? Use the default debug messenger, and that's the instance. And finally, if not instance, then we need to do something about that. And I believe there is some good error handling for that somewhere around here, which I couldn't find for whichever reason, though I believe there is some in the example though. Like if you go to maybe basic usage, for example, there you go. So you just say like instance return the error. So actually this is just the instance result, really, right? And so if not the instance result, then we could just say error message, error.message. Alright, so basically instance result the error dot message apparently, and that's your error message. So what we're gonna do about this, let's see. Yeah, I think we're just gonna do something similar to this, right? Result VKB instance, or you know, let's just copy this for now at least. And for the lock, it's gonna be yeah, the lock here wouldn't really work out the same. Lock. But anyways, let's just do this. std source location lock. And instead of SDL get error, we're gonna go with this guy. And this is a string, so we gotta make sure to pass in a CSTR. Though since that's a string, we should probably store it. Auto message is equal to this guy. There you go. And yeah, so that's the error handling of that part. And then I guess you could just say std exit 1. And there you go. Next up, we could just grab the instance is equal to instance result dot I believe just value. Yeah. And there you go. So next up, I think we should be good with the instance. Let's see what else we need here. We need the surface. And honestly, we don't really... Yeah, so after that, we're just going to create the window, as you can see here. And finally, before we even show the window, we're going to try to create the surface. So for the surface, how are we going to do this? Well, we're going to use check SDL, SDL Vulkan create surface. And we're going to give it the window here. Then the instance, which is like instance dot instance. And then what's next? The allocator. Well, for the allocator, we could just say allocator. We'll see in a second about that. And then the surface would be this. So hold on a second. So the window, before the window, we're gonna have like a vkb instance. So like instance. And next up, we're gonna have, we could also have like an allocator, fine. So it's gonna be a null pointer, but let's just have it anyway in case if we ever want to experiment with that and see what it is. We're gonna have it there. The other thing right now is, well, honestly, this guy could just go, I don't know, maybe somewhere around here, fine. And in fact, since we're using that now, can I use it here? Fine. It's null pointer by default, so that's fine. Okay, next up, the instance. So how are we gonna deal with this? Yeah, so we're gonna just do it here, fine. Next up, in the window, and finally the surface. So vk surface khr surface, and let's go. Now here we got like the instance. Well, here we're just gonna use this. Wait, do we even need that really? Wait. Yeah, actually, never mind. This is fine. Okay. Now that we got the surface, we could go to the next thing, which is selecting a device. Now to select a device, what you do is you create this vkb physical device selector. Right. So physical device selector. And yeah, we could just call it, I guess, physical device selector, fine. And then here you give it the instance. And also the surface. Sick. And what you do next? What you do next? You could set the selector, then select. Okay, so you could just basically say physical device is physical device selector dot select. What else there is there? Select device names. First device and conditionally, interesting. So anyways, and this is also a result, which is kind of annoying, but anyway, let's just copy this for now. So this is the physical device result. And actually, let's fix this for a second here. I think it's supposed to be like this, okay. And now we're gonna just use this, oops, this and this. And the message, yeah, cool. So So after that, we could grab our physical device. Yo, I'm back. What have you done until now? Lazy Silly, welcome to the live stream, or welcome back, should I say. So far, I've just, you know, have fighted the CMake gods, making sure that everything works out fine in that front. Other than that, I set up the SDL main callbacks, and then I'm setting up right now vk bootstrap, and yeah, that's all we've done until now. Right now in the physical device selection, and yeah, and for the vk, like, where's the physical device selection stuff? Physret dot value. Nice, yeah. All right, so the physical device here is like physical device, and what we're gonna do next is like the instance to get the window, get the surface. Now for the physical device, we're gonna say that it's equal to the physical device result. Whoops. The value, there you go. And what we're gonna do next is the device builder. So the device builder, okay, so VKB device builder here. So the device builder, isn't Vulkan overkill for a browser? GFT clips, welcome to the live stream. No, it's not an overkill. Vulkan is pretty much the only option if you want to make a cross-platform. I mean, you could use OpenGL, but it's not what people is using nowadays for modern stuff. What can I say? So like Chromium, for example, uses Vulkan, Unity uses Vulkan, Go.Engine uses Vulkan, Blender uses Vulkan. Everyone is using Vulkan under the hood. But one catch though here is that we're not going to be creating the render itself in Vulkan. That would be an overkill. What we're doing is using Skia renderer. So but using Skia render, you still need to create the first Vulkan kind of like an SDL skeleton. So for example, I mean, in fact, you're gonna see this when I get to it, but we wouldn't need to create a command, what is it called? Command pool and command buffers, and we only have the responsibility to create the swap chain, the Vulkan context, and other stuff like the window, the input, etc. Because like Skia, you just give it like the Vulkan context and the swap chain, and then it does the rest for you, essentially. So yeah, it would be an overkill if we created the Vulkan render itself from scratch, but just for using Skia and with Vulkan, that seems reasonable. I mean, it's still low level, but I can't think of a better way without losing control of what we're doing. Another way we could have done is using Go.Engine, and then just like extending Go.Engine with like web nodes and stuff, and using that to create a browser. And honestly, that would be cool experiment to try with an actual AI agent. But I actually made a vote on my YouTube. Hold on. Yeah, I made a vote on my YouTube. Should we use Go.Engine or make one from, or like make an a web browser from scratch? And most people have gone with voting to a web browser from scratch, so we're doing that basically. And another thing is that I could get using like the stuff that I learned, like Vulkan and even Skia, which even Chromium itself uses, and Flutter was using at some point, but nowadays they have their own renderer called Impeller. But yeah, but even if you really want to make your own renderer for your browser, I'd really recommend at least starting with an existing render like Skia, and then later on, if Skia isn't enough or whatever happens, you could switch out and make your own, and at that point you'll have a very good skeleton to start off from and inspiration from how Skia does it. So yeah, that's hopefully that answers your question. Next up, here we got the device builder. You need to give it the physical device and the device info, isn't it? Cannot initialize local variable. What? Why? What do you mean? The device builder value type, but like what's actually here wanting? He wants the VKB physical device. Well, if you're not going to use an existing engine like the Gecko engine by Firefox, it's going to be very hard and painful, especially for security bugs, etc. Yeah, obviously we're not trying to make like the next Chromium in here. It's just like mostly an experiment to see how it would look like with a modern stack, and trying to make like use as like Gecko engine. I think, I mean, you could even use, what is it called? Chromium Ceph, I think it's called. Yeah, I think it's Chromium Ceph or something. But at that point, you're basically like having that whole engine, which is huge, first of all, and I don't even know how to build it. And another thing is modern engines have a lot of cruft from history. Like they still need to support old renderers, and yeah, and also they have multi-process architecture, which obviously is good for security and stuff. But either way, what I really wanted from this project is that the thing is, how I thought about it is that I have learned a whole lot of these libraries like SDL, Skia, and all sorts of things. And I thought about which project would allow me to use all these libraries together and like fit them like Lego blocks. And the best project I could think of is a web browser to test my skills of integrating all of these libraries together, and obviously also Vulkan thing too. And hopefully at some point you could even get FFmpeg on board. But yeah. Also another thing, if we use something other than raw Vulkan, we can't use, for example, let's say FFmpeg Vulkan decode. Which basically uses the GPU and like zero copy for the videos. But yeah, either way, this is just mostly an experiment live for people to learn and for me to learn, and also to test a few like AI workflows from time to time. And also another thing is that this project would be open source. I would publish it, and if anybody wants to contribute, feel free to do so, and we'll be reviewing your contributions on stream, kind of. And basically also, if anybody wants to contribute and they want to understand how the project works, they could basically like watch these live streams and see why I've done what I've done. But yeah, either way, it's just a good experiment at the end. Do you have a rough idea of how to handle networking? Are you going to use an HTTP lib? For networking, I have no idea yet, but I have a rough idea, shall I say. So for beginning, we're just going to use a simple libcurl, right? But that's obviously not enough for a modern browser, because you need async and you need all sorts of cool stuff. So for that, what we're gonna use is probably Boost ASIO library, Boost ASIO, and also maybe Boost Beast. This is also like a Boost library. This is what I want to use at some point for the HTTP, like for the networking part, because that's the best, I think, in terms of libraries. Though please make sure, like, if you have some other suggestion, please let me know. But obviously these ones are pretty complex to set up and use, and also obviously you also need like OpenSSL or boring SSL or whatever for the SSL, because you know web nowadays don't use HTTP, they use HTTPS. But at first, we're not going to be using these. These are a bit complex for now. Just to start off, we're going to only be using libcurl, which you basically just give it a link. It gives you back an HTML document, and then you could feed it to light HTML. And yeah, I'm a C dev, so I don't really know C++ that much, only just certain level, but I'm going to try to contribute stuff on common dev. Sure. Though for now at least, because like the project is just starting out, I'd rather just get issues instead of pull requests. And like if you have any suggestions, you're gonna put it, or whatever, you're gonna put it in the, or the bug, you're gonna put it in the, like there. Anyways, so yeah, either way, it's kind of like an open source experiment to some degree, and since I have YouTube, I could have some exposure. It would be much easier for me. But anyways, so here we got like the device builder. So my point is, how far can we go by trying to make a web browser by just gluing together multiple libraries, multiple open source libraries that does specific isolated task. For example, for HTML and CSS, for example, we're going to be using light HTML instead of like building the whole stack ourselves, right? So that's kind of the thing here. But yeah. Okay, so the device builder here, we need the VKB physical device apparently. Oh, okay, I see. So this shouldn't be this way. This should be VKB. And also, it would be great for people to see how they could integrate Skia, Vulkan, SDL with CMake and all sorts of these crap. This is also a really great project for me to show how you could do this stuff. Another thing that I want to also experiment with in this project is how to structure a project. And to be honest with you, I also myself struggle with this, but we're gonna see how it goes. And we're also gonna be hopefully also using AI agents and AI chatbots to just assist with prototyping, with hopefully even testing at some point, and like planning, etc. I didn't use so far AI that much, like the AI agents, because in the previous stream, if you have watched that, we actually were trying to set up Skia using it. And obviously you can notice that since the agent did all the code itself, I didn't pay attention to such quirks that was needed, for example, for the CMake. So I would just fall into those traps and I had to figure out myself. But at least the agent have kind of like proven to me that first of all, it is possible. Second of all, that it gave me like a rough idea on how it should go, on how it would work, right? And then in this stream, what I did is that instead of using the agent code, I just have gone myself and tried to make it line by line. And obviously also I get to choose exactly how I want to code it instead of the agent itself. So yeah, for example, let's say the error handling, let's say, for example, here I used my std source location and SDL log error, etc. Let's see what the agent, for example, did in our previous experiment. Kodoki, src. Obviously I did work on this like off stream too, so this is not as simple as it was in the previous stream, but let's see what it did. Okay, so we have a few things around here. So yeah, for example, for the error handler, I just used exceptions instead. Yeah, and it didn't use like SDL log error. But either way, whichever. And this just kind of stays as like the reference code. If we ever have some problem, we could reference this code and see how the agent did it. So yeah. All right, so if you guys have any other questions, please let me know. Otherwise, we're gonna go to the next thing. So we got here the device builder, and it basically requires the physical device here. And is there any other arguments? I don't believe so. Yeah. Okay, and in fact, before I forget, we need to add the SDL extensions. And how are we going to do that? Well, we need that before we create the instance. Apparently we need it in here before this, I think. Right, yeah. Okay, so let's actually do that. Let's do it. And for that, what we're gonna do, so I believe it was basically like UN32T, the extension count, like instance extension count, okay, is equal to what? To SDL. Well, actually, let's just keep it that way, and then we can say auto instance extensions or extension names if you want that, and we could say SDL Vulkan get instance extensions, and here you gotta give it the instance extension count, and boom. This is the only contribution that I made to SDL3, by the way, which is this function. Because at first, what they were using, they would basically require you to allocate memory for the instance extensions. And I've just contributed a fix where you don't really have to do so. It just gives you a pointer straight to an array, depending on the platform. That's, I think the single, maybe I have contributed other things before, but at least that's the thing that I really remember well. But anyways. So that's interesting. Anyways, and here we could even create an instance extensions out of that. In fact, we could even go ahead and do it this way and just grab that. Yep, there you go. And we could make use of span. Let's go. So here you give it the pointer and the count, and then it makes a span for you. And let's see how you're supposed to add it in here. Extensions, right? Enable extension or enable extensions. And look at that, it does actually support spans, so that's perfect. You could just say instance extensions. Oops. And actually that doesn't work apparently, unfortunately, for whichever reason. Maybe, what if we do const here, I guess? No. Yeah, for whichever reason this doesn't work. Probably something to do with const mismatching. But that's fine. We could then do it ourselves. What we could do is just have the instance builder. And then just do it like the Stone Age way. Just go through all the instance extensions and instance extensions, and obviously we need to say auto, and then we could say instance builder to add extension. Wait, what? Oh yeah, enable extension, my bad. And then you could just give it the instance extension they want to enable here. And let's go. And boom. Alright, next step, what we're gonna do now is, well, obviously we're gonna build that. Build. Boom. And there you go. Now, has already been defined or declared. Okay, I see. So we could just do it this way, all right? And boom, there you go. Is there anything else I missed here? I don't think so. Other than that, let's go back to the device stuff here, and let's see what we got here. You could add a P next, and you could build. How do you add an extension? Where the heck is extensions? Strange. What? Oh, you're supposed to add it into the physical device. I see. So then you add it there so you could basically check for if those extensions first exist, make sure that's the case, then it basically kind of like hands them over to the device builder. Gotcha. But where is the swap chain extension? Well, let's actually check out the actual official example. And where is even that? There you go. And let's see. Here, obviously, it doesn't need that, so we didn't use it. There's the system in. What the heck is the system info? I've seen it beforehand, but I'm not sure. Oh, you could use it to check for a layer and to check if the extensions are available even before building an instance. Ah, all right. I see. I don't really need that for now. Okay, and let's see how they build the device here. Hello, hello, hello. All right, so how are we gonna handle this? Let's see. Like, where's the swap chain extension? That's the question here. That's weird. Okay. Okay, where is it? Yeah, let's check out the source code of VK Bootstrap, to be honest with you at this point. Source VK Bootstrap. And where is that? So when it's creating like the VK device builder, yeah, there you go. And it just moves. Okay, and the build function here, what it does. So what we got here, extensions to enable. Okay, so as you can see, it grabs them from the physical device. Okay, wait. Look, okay, so it actually enables that automatically, as you can see here. Yeah. And there's this defer surface initialization for whatever reason. I'm not sure what's that. But either way, it automatically does that for us as long as you have already set the surface on the physical device. So yeah, that's sick. Alright, so let's go, I guess, to the next thing here, which is to basically build this. So VKB device. And like then the device is equal to the device builder. Though I do think it would give me that result again, which is really annoying, but whichever. Auto device result. And then we're just gonna copy this kind of thing for now. And if not physical, okay. And we're gonna log the error device result. Yeah, cool. And then we're just gonna grab the device. .build. What the heck? No. The device result, okay. .value. And boom. Copying an object of type VKB device. Yeah, just making sure. Alright, so that's sick. That's cool. So now we got the context finally done. What we're gonna need next is the swap chain. And using some modern extensions, we won't even need the sync objects like the fences and the what is it called? The semaphores, right? We don't gonna need that. You're gonna see how that would work. And another thing is that we wouldn't need a command pool or command buffers because those are done by Skia themselves, right? So yeah. All right, let's try to create a swap chain next. And how do you make a swap chain? So let's go back to, no, I don't think they're creating it here though. Okay, let's see how they're creating the swap chain. There you go. So you just created a swap chain builder apparently. Then you set the old swap chain. Oh, you actually even have a vk result, which is interesting. And then you just say vkb destroy swap chain. Ah, okay. All right, that's sick. That's lovely. So how are we gonna do this? So you're gonna say swap chain is equal to what? To the, well, actually you're gonna create the swap chain builder, my bad. Right, and then you're gonna say swap chain builder, and you need to give it like the device, and I don't need that. Now what we're gonna do, let's see what we could actually say here. Yeah, there's some interesting stuff here that we could see about later on, but I think for now we could probably just say swap chain is equal to, well, obviously we're gonna do that result thing again. Okay. Dot build. Wait, what? No. Can you use device like this? And same thing here. And but instead of device result, we're gonna use the swap chain result. Yeah. And there you go. Now what's next? We're gonna see about that later on. We also need the queue though. So device.get queue. Data.graphics queue, that, and you could even grab a present queue too. So what type is that though? Like, I think probably vk queue. So we could do it here, like vk queue. Device queue, or, well, graphics queue, my bad. And then you could have a present queue too, because why not? And then even before the swap chain, you could say that the graphics queue is equal to the device, I believe, .get queue. Okay, so you could actually use get dedicated queue and index, because the queue alone just gives you a result. I see. Okay, get queue index. Gotcha. Right. So the vkb queue type. Whoops. So you could either use graphics, present, transfer, etc. So you could go with graphics. And obviously this actually does give you a result again. Annoying. Anyways. And man, like copying that over and over and over again. Okay, let's see. So vkb result, vkb device, vkb result, vkb swap chain. You know what? Maybe I'll just make some templates. Hopefully I don't regret this, but yeah. Alright, so check VKB, and we're gonna have here I think VK bootstrap result, right? Or VKB result. And here's some T value, and then we're gonna use a template here. I don't even remember how do you create template, bruh. I think class name T, isn't it? Or like, I guess maybe something like this. Yeah, I genuinely don't even remember how do you create a template. Yeah, that's what I've done, I think. Or like class T, or even type name. Anyways, whichever, I don't care. And what we could do next is, yeah, that's basically that, I guess. Yeah, I think that works. But right now we're just gonna grab our, I mean, we haven't changed much. We just need to grab this message, right? Log file name, log line, log column. Instead of SDL get error, we're just gonna go with the message here. Though I think .c is error, right? There you go. And another thing also that we could add here is the message, well, not the message, the result.error. I believe there is even vk result or whichever. Yeah, there you go. So sure, let's add that too. Why not? And let's just, I guess, add it something like this. I mean, I think vk result is kind of like, yeah, I think that should work fine. And now we could replace a lot of that stuff. So we could just, instead of this, we could just say check. And actually, wait, otherwise we could like return, can we do that? Like result.value, which means we're gonna return T, possibly. Yeah, that's sick. So now, instead of doing this business, we could just say yeah, we could just remove this stuff and just say this check VKB, and boom. Alright, that's way better, bro. And we could remove this too now and just say check VKB physical device result. Way better. And same thing with the other ones here too. Look at that. So check VKB device result. Next up, we got the, and honestly this one too, we could say that the graphics queue is just check VKB that. And let's go. So this should actually be like this. And we're gonna do a similar thing for present queue. And let's just rename that to and present. And boom. Okay. That's sick. And we're gonna do the similar thing here. I should have done this earlier, to be honest with you. I just was lazy. But I ended up, yeah. Anyways, so we're gonna say swap chain builder.build and boom. And let's go. So that's way cleaner, bro. It's way cleaner. Alright, so we got the graphics queue, the present queue, we got the swap chain, the surface, the physical device, and everything is checked out. Yeah, I think we're pretty much good to go. And whoopsies. Failed to create a swap chain. Why that's the case? Why? Let's see if I could see if there is some obvious error here. It doesn't seem like an error though. Oh. Alright, so I see. And yeah, something is working. As you can see, here's my window, but we're not rendering yet, so it's not showing anything. Okay, so I believe we're pretty much ready. We just need a few extensions that we're going to be using for the swap chain to really simplify a lot of things for us, which is these guys: the swap chain maintenance, the shared presentable image, I believe, and present ID, and possibly present weight too. But let's not add them now. Let's keep them for until like we have an error. Fine. So we could see where each function come from exactly. Right, so what are we gonna do? Alright, let's see what we got here. I'm not sure we do need that dispatch table, I believe. I'm not sure, we'll see. Other than that, what else we gonna need here? Acquire and signal. Have I not done that? Like, wait. Present ID, services. Anyways, let's just see how this works. So first of all, we're gonna need to create this Vulkan backend context. And how do you do that? Let's find out. Okay, frame resize, blah blah blah, whichever. Let's see. So backend context, and kind of like you just inject the what is it called? The Vulkan stuff that you made. The Vulkan, yeah. And make recorder. All right, let's just grab this part for now, and let's see how we're gonna do it. We're gonna do it manually. And just inspiring from whichever we have here. So apparently I need the hello precious 2383. Welcome to the live stream. So what is this type though? This type is the SKGPU. So it's coming from SKGPU. Okay. Now obviously for that we're probably gonna need some sort of a header. GPU Graphite. Okay, so either from Graphite or Ganesh, which GPU backend you're going to be using. Obviously, we're going to be using the modern one, which is Ganesh, which uses Vulkan, because the other one uses OpenGL, I think. Let's go. Alright, so how are we going to do this? Well, we're going to say, I believe, include first of all, and then GPU, and then you got Ganesh, Graphite, MTL, Vacay. What's going on here? Oh, here we go, Vulkan backend context. Wait. There is two here. There is like one VK inside of graphite and one VK inside of... oh, that's the Vulkan graphite context. Gotcha. So here we just need the Vulkan backend context. Fine. Many seem like an experienced CPP dev. I'm sorry now, CPP is a complete new. Why should I start my journey with projects? I like game dev too. Can't really tell you much honestly without knowing your background, what your goals are. But yeah, I would just recommend just learning by project. Just pick up projects and just try to make it, and help with AI, help with tutorials, etc. And yeah, I think that's what I got for now. Yeah, I don't really have some specific advice. Yeah, not really. Though maybe it would be better if you haven't started with C. I would guess maybe it would benefit more from starting from C, then going to C++. Because C++, there's just a lot of business that you're not going to understand a lot of things. Rust also actually helped me learning about ownership and RAI and all sorts of things. But other than that, yeah, anyways. So right now let's just create this Vulkan backend context thing. So SK GPU. Okay. And yeah, let's see how this works. So you got the Vulkan backend context. You set all that stuff right there, the device. But wait, actually no, that's just, I believe, just a struct. Isn't that the case? Yeah, that's just a struct. So no need to actually create it here though, I believe. We'll see how that goes. And then you could literally do this, design initialization, and here you could grab the instance, the raw instance obviously, not the VKB one. Here the physical device, same thing, physical device. The device, same thing, device. The queue, which queue this is? It just says FQ. Doesn't say. I would guess it's graphics queue, obviously. So yeah, let's go with that. The graphics queue index. I don't think I grabbed that just yet, but I should do so. But for now, we could just hard code it as graphics queue index, and we'll define that later. Here, the max API version. Well, we're gonna go with VK API version 1.4. The FVK extensions. I am not sure. I think I'm supposed maybe to give it like the extensions that I enabled, possibly. But for now, let's just say null PTR. We'll see about that in a second. The device features. Same thing. Let's just say null PTR for now. The F device features, same thing for now. We'll see about that later. The memory allocator, I think we could just do this next. If get proc, we'll see about that in a second. The F protected context, yeah, I'm not sure about that either. Let's just, I don't know, no BTR maybe. Device locks to context. Yeah. Whoops. I think that's the last one. Okay, and let's see what the heck is going on here. If device proc. So okay, now in our case, what we even done in here, well, in fact I already got the code here. So obviously the instance in the physical device and the device, the graphics queue, here the graphics queue index. In fact, let's make sure to take care of that part. The get queue, so we could use get queue and index. They would give us an SCD pair apparently. Okay, well, I think we could say graphics queue and like graphics queue index. I think that's how it works. Shadows declaration. Well, I don't know, like let's do something like, well, let's just do this, right? And then we're gonna do a similar thing for the present too. And finally we're gonna set the graphics I think we should supposed to do this, then the graphics queue index, and then the present queue index is supposed to be present queue index, then the graphics queue is supposed to be the graphics queue, and then the present queue is supposed to be the present queue. Now obviously let's add these indices here. You enter E2T, and then you enter E2T, the present queue index. And let's go. All right, I think that's good now. All right, what are we gonna do next now? Well, now this works perfect. Max API versions. Okay, so what it did for the other ones, the get proc, we'll see about that in a second. And for this one, it says SK GPU protected K-no. The protected context. Is the data protected on GPU or not? No. But isn't it already the default anyways? Yes, it is the default. So we could even remove it if you want to. But let's keep it fine. Alright, what's next? The memory allocator. So for the memory allocator, what they did is SK GPU Vulkan memory allocator. Why I can't do this? Maybe I need to include some header. Let's see, Vulkan backend memory allocator, maybe that. Alright, let's try. So if I include Vulkan memory allocator there. Would I get access to the make function here? No. What in the world, bro? Oh yeah, it is actually Vulkan memory allocators like this. Oh, cause like that's the factory thing. Yeah, but like where the heck would I find that? Oh, I think maybe that priv thing or something. Is that the case here? Yeah. But why it's in the source code? I think maybe I'm supposed to like make my own or what? Interesting. Yeah, is this like, oh, so it's virtual. Ah. So basically maybe I'm supposed to like implement it by my own by including VMA myself if I really want to, but for now let's just use that SRC thing. Fine, who cares. Now the make is you give it the backend context. I mean, that's interesting. So like you're supposed, I guess, to say, yeah, that's weird. Vulkan backend context. And then the thread safe. Currently it's not, but I guess maybe you might need to change it at some point, I guess. But I don't have that symbol. That Kano. Okay. So yeah, I probably need to grab it from somewhere again. Maybe this? Possibly. Yeah. Cool. Alright, and next. Next up, finally we need the git proc thing here. So let's see this git proc. Okay, let's see here, git proc. Where they're creating that backend context again? Here, there you go. So this is the git proc. I don't understand what the heck they're doing here exactly, but let's just copy this for a second and let's see how this really works. Alright, what's going on here? So it's basically grabbing that from the instance. Okay, it's grabbing. I see. So it didn't really need, I guess, to make a table, or did it? Actually, it does, I think. Yeah, it does. If you want to use it, I guess. But anyways, so here the vacay fp instance fp get device proc addr. Aren't you supposed to grab that from the device? Yeah, I think you're supposed to grab that from the device. Yep. Alright, I mean it would work from the instance too, but the device is better. Next up, you basically get a name and then an instance in the device, and then you're supposed to return some sort of a function, a Vulkan function. And what they're doing there, they're checking if the device is not equal to vacate null handle. Then they're returning the GDPA. They're using the device. Okay. Get device proc ADR. But if there isn't, otherwise they're returning the instance function. The GIPA. Yeah, that's good. That's good. Fine. And we're gonna pass it here. Cool. Yeah, that's interesting. All right, next. I believe they didn't set the other stuff. Yeah, so we could just, I guess, remove it for now. But what are those, in fact? Let me check it out. What is that? Optional callback, optional, which will be invoked if a vacate device lost error code is received from the driver. Vacate xt device fault. I see. So that's good for reliability, but we're not going to go that far for now. So the client must provide an implementation of Vulkan memory allocator for Skia to use for allocating a Vulkan resource that use vacate device memory. Okay, so ideally we should probably maybe make our own implementation apparently, but for now I think the other one works. Next up, the clients can create a vacate device with either vacate device features or vacate device features too. Thus we have to support taking both the vacate. So if we know the client enabled any extension specific feature. If vacate is not null, then we ignore. If both and are null, we will assume no features are enabled. Alright. Gotcha. Well, that's interesting. And then the max API version here should match the value set in. Gotcha. And here the Vulkan extensions. And apparently it's a pointer. What is that? Okay. I believe there was another thing which is like, wait. Let's see. Include slash, well, hold on. I think it was vacate, no? No, GPU first, then vacate, and then... Okay, so there was this Vulkan extensions thing, and there's also preferred features. So let's include both of these. And let's see what's up with this. First, actually, let's start with this. Why not? Fine. So what's up? SK string, Vulkan types, blah, blah, blah. So a helper class that eats in an array of extension strings for instance in device and allows for quicker querying if an extension is present. Huh. So you give it like the Vulkan get proc, vacate instance, physical device, an instance extension count, and then instance extensions and device extension count, device extensions. And you could check if it has some sort of an extension. Okay. Okay, interesting, but we'll see about that, I guess. Next step, we got this. Is used by Skia to add extensions and features on top of what the app wants to enable. The flow of Vulkan initialization for an app that wants to use Skia would be query the loader for instance information, decide on API version to use, prepare for Skia enabled extensions and features. Gotcha. Decide on instance extensions to use in the app, allow Skia to add to the instance extension list. Allow Skia. Create the instance, choose the physical device, query available extension, decide device features to query, allow Skia to add to the feature query list. Yeah, I think maybe these like structs are basically used to tell Skia what features and extensions you enabled or something, or that it wants to enable. I don't really understand what's going on here. But you know, for now what I'm gonna do, I'm just gonna go with like there's no features or extensions enabled, which is not gonna be the best performance, I guess, maybe, or whichever. But it should work for now, because like my agent code didn't use any of that stuff and it was just fine. So yeah. Okay, so I think all of them have defaults, right? Yes, all have defaults. Okay. And I think we're good for now, right? Until now we're good, right? And boom, we got a linker error. And this linker error is about the Vulkan memory allocators make. Interesting. Right. I'm gonna have a little break and then I'm gonna come back. Alright, back. Okay, well, let's see where this linker error is coming from, and we're gonna use the AI for that. All right, so gotta enable graphite. There you go. Skia enable graphite equal to true. Okay, so the mic is on. Cool. The live is good, right? Anyways, let's go back to the business here. Skia enable graphite equal to true. And let's build again. And oh boy, it's gonna compile again. I should have done this honestly on my break, but well. Alright, so apparently even after including that graphite backend, it's still complaining. Oh, I forgot Skia used Vulkan. Wow, come on, bro. Okay, so you basically enable these two features. My god, it's gonna recompile again. Crap. Yeah. Alright, so to be back, I guess. Be right back. and it's done. And right now I actually don't have those linker errors anymore, which is perfect. So basically I just had to like add Skia enable graphite and Skia use Vulkan, and there we go. Alright, so I don't give a crap about these kind of errors. Please don't bother me. Thank you so much. C9 functions is always the same. Disable inspection. Thank you. Let's go. Okay. So now this works out. So we're creating the Skia Vulkan backend context. Alright, so what's next? Well, we're just building, I believe, this guy, right? We still need that context option thing. Apparently, okay. So you just say SKGPU graphite. Okay, so here we created the Vulkan backend. Now we're gonna create the graphite backend. Well, actually, no. This is just like an info structure, really. But you got the point. Anyways, graphics context factory. Okay. So SKGPU graphite. What? There's no graphite factory here, so I would guess we need the headers. Graphite context. Okay. So let's add the graphite headers first. Okay. Include, right? Cool. Slash graphite or GPU slash graphite slash I think the context next, right? And now what you do is you just say SK GPU graphics, and you have all these things, and I believe you just create a context. Wait, what? Hold on. SK GPU graphics or graphite. There is context factory. I have no context factory here. So yeah, probably another header, bro. Graphite context or factory or where the hell is this factory, bro? Or maybe Vulkan graphite context? Yeah. Yeah, maybe that. Now if we do SK GPU graphite Vulkan or VK, make Vulkan. Okay. In the context factory namespace, sick. And here where you give it like the Vulkan backend context, and then you're supposed to give it some context options. Some graphite SK GPU graphite options, context options, obviously. Context options. And yeah, you gotta include some other crap apparently. Probably in vacay. Maybe Vulkan graphite types. Is that what we need here or something else? No. Actually, just graphite, I believe, and maybe context options. There you go. And you just give it here. Now, what this returns for you is a unique pointer context, apparently. Interestingly. And you just store it, right? SKGPU graphite context. And same thing with like recorder and stuff. Interesting. Okay, let's just grab that. Thank you. And we're gonna do this. And then we're just gonna say, well, let's remove this stuff here. Well, we're gonna set that to the context, right? Perfection next. After you got the context done, yeah, you gotta check for errors, obviously. If not the context, then you just fail to create graphite Vulkan context. Okay. And for that, we're just gonna say if not context, then apparently SDL log error. Failed to create graphite context out, yes. Well, hold on a second. SDL log error, blah blah blah, whatever. S comma, or you know, let's just go with that. Actually, fine. I believe you could probably get the error somehow. No, I don't really see a way to do so. So yeah, and if a error happens, we're just gonna exit, bro. There you go. And finally, you could actually make a recorder and build the SK services. Okay. A recorder. So basically, these recorders, you could build them in every thread. That's kind of the thing here. So they're like a command pool. Even like command pools, you create them per thread. So you could basically like have multiple threads, which are recording command buffers. And you would have like one recorder per thread. Or other than that, I believe there's other things too about that. But anyways, this is irrelevant right now, really. So let's just add a recorder for now without any philosophy. SK GPU graphite recorder, I believe. And let's go. So notice we don't have a command pool or whichever. All of that is going to be done by Skia itself. It's the renderer. Okay, at some point maybe we're going to split the render from the platform, etc. But right now, let's just keep it that simple. Sick. And finally, we're going to say recorder is equal to context. And there you go. You have all of these cool functions on the context. Yeah, but we're just gonna make a recorder. There's even a CPU recorder. I have no clue what the hell is that. Make a precompile context. What? Okay, make recorder. And here you got some options apparently too. But yeah, that's basically the case here. I wonder what are these options. Anyways, whichever. Okay, so we got the recorder now. Perfection. Next thing that we're gonna do is, yeah, I can't believe this haven't been done yet. So the surfaces. The surfaces is interesting. Graphite. Mode exclusive. It's grabbing some extent. Where is the extent coming from? Oh, it's putting it here. Okay. Alright, honestly, I'm just gonna steal this function at this point. It's just nothing really fancy there. I think. Yeah, because, well. Alright, let's see what we got. Do we really need this acquiring signal stuff? Yeah, apparently we do. At this point, I'm getting very tired. I mean, how much time we've been? 4 hours. Yeah, I think at this point, honestly, I'm gonna stop the stream, and we're gonna continue maybe, or you know what? Because I really want something working on the stream so you can guys see it. Yeah, I think let's just go. Let's just do it. Let's just do it. I don't care. I'm gonna actually copy a lot of things here because this is nothing fancy really at this point. Destruct frame. Okay. And we also have this max frames thing. And the frame acquire and the signal. And well, we gotta actually add these things in a second. Okay, create semaphore. Yeah, I'm zoning out at this point. Anyways, let's just steal this rebuild services function here. And where are we gonna put it? And it's going through the swap chain images. Yeah, I haven't got that swap chain images. I forgot about that point. And how are we gonna do that? Well, here I think. So like swap chain images. Let's check. Or isn't it? Wait, no, I don't think. Oh, we already have. Wait. What? That's weird. Anyways, let's just try say swap chain dot get images. There you go. There's even get image views and get images and image views. Though I don't think we need image views here because I think it's gonna be basically created by the render itself. But we only need like the images, I believe. And this would actually give me back a result. So I'm gonna use this check VKB again. Other than that, this is gonna give me a CD vector vk image. I'm gonna put it alongside the swap chain because, well, why not? Right. Did I, by the way, enable the mic and everything? Yes, I did. Sick. Swap chain images, fine. So that's the swap chain images. Next up, and here we're just gonna make sure we're using them. And yeah, surface clear. So every time we rebuild the surfaces, we clear all the surfaces, and then we create this texture info, and we're supposed to grab the image format from the swap chain, I believe. Yes, and the extent. Can we grab the extent from the swap chain here? Yep. So the height here and the swap chain dot extent dot width here, and wrap the backend texture. I need to find the include for that, and here the recorder is basically this, and the SK color space, it needs its own include too. Oh boy. Where are we gonna find this stuff? Well, good question. Good. I think backend texture, at least that's probably one of these. The other one, let's see what we got left. Wait, we'll definitely need backend semaphore too at some point, and maybe the surface too, and like the texture info and such. Okay, so that's one error down, and then the SK color space. Where the heck would I find that, bro? The SK color space. Where that could be, maybe mutable texture state. Is that the case? Oh, it's actually in core. Okay, gotcha. Include slash GPU slash, well, core, sorry, and SK color space. I could have just copied that code, but well, we gotta know how this works as much as possible. Yep, I think that's good for now. Though I don't want to use these guys, but you know, I don't really have the time right now, so fine. Let's go to the next thing here. Yeah, so at the start of the frame, we're gonna like rebuild the surfaces, right? So before we show the window, rebuild the surfaces. Thank you. And we have even a recreate swap chain, but we're not gonna use that now. Where we're creating the semaphores and stuff though. Yeah, it's right here. Let's just grab that. Memory allocator. Then we're gonna need like the max frames here. What? Wait. Let's put it here, why not? And I think we're good now, right? Instead of vacate check, well, we don't have a vacate check yet. Interesting. You know what? I'm so lazy at this point, so let's just copy this too. We'll basically fix it later on to fit the other ones. Just like the other ones. At this point, I'm just trying to get something on the screen. Though I need to, you know what, let's see, if result is not equal to vacate success, then just do this, fine. And let's grab this lock. And for this one, I'm just gonna say check like this. And we don't need a message here. And instead of SDL get error, well, obviously we're just gonna go with the result. Though this is just gonna be a D there, and there we go. Okay. And now what we're gonna do is, where's that guy? So we're just gonna say check and check, and we don't need any of this business. And here we need like a dispatch table, I think. Do I really need that? Yeah, I think I do. Yeah, okay. So we're gonna make a table. And what is gonna be its type? Dispatch table, okay. Or is it really from, yeah, that's good. So let's grab a dispatch table there. Where I'm even gonna put it, maybe after the device creation, fine. So dispatch table in VKB, okay. And fine, let's call it, I guess, DT, or maybe vk. I would like vk more, honestly. And here you just say vk is equal to device.makeTable. Though actually, wait a second, let's rename it to vk this. And now we could just use that here and here. Well, the allocator, let's just use that. And that's how you create a frame. But yeah, cool. Next, what we gonna do next? Make recorder, make Vulkan. Oh boy. Get swap chain status, give Windows size, acquire next image. Yeah, we're definitely gonna need this, acquire next image. Yeah, I think honestly I'm gonna stop this train at this point. I'm just so exhausted at this point. So we're gonna continue tomorrow. Alright, so see you guys.